J Institutes of Engineering and Technology. In this current video lecture series, we are studying subject of Physics Group 1. Till now, we have learned what is elasticity, concepts of load, concepts of stress and strain along with the Hooke's law in the chapter of properties of matter. Now in this video, we will learn the topics such as stress strain curve, or we can say that the relationship between stress and strain, few important properties of the materials such as ductility, brittleness and plasticity, along with the working stress and factor of safety. So let us start with the first topic of today's session, that is stress strain curve. As you can see in the figure, there is a graph of stress versus strain. The relationship between stress and strain is known as the stress strain diagram. Following are the salient points which I am going to cover. Okay, that will be all about the graph. So first one is the limit of proportionality. You can see the point A in the graph. That is the limit of proportionality or proportional limit. In the range of OA, the strain is proportional to the stress and the graph is a straight line. Okay, the point A is known as the limit of proportionality because up to point A, the stress is directly proportional to the strain, and because of that, the graph is a straight line and it obeys the Hooke's law. So it is the value of the stress up to which the strain and stress have a constant ratio. Okay, and it follows the Hooke's law. Now second is the elastic limit. At point A, the curve deviates from the straight line and the graph from A to B is non-linear, as you can see in the figure. If the load is increased beyond point A up to the B, the material behaves in elastic manner, means on the removal of the load, the whole deformation will vanish and the material will regain its original shape because of the elastic nature. Okay? The value of the stress corresponding to the point B up to which the material behaves as a elastic material, it is known as a elastic limit. Up to point B, the material will be in elastic range. Beyond B, it will come in a plastic range. Okay? So that is now the third is the upper yield point. The point C is called as the upper yield point, and at this point there is an increase in the strain even though there is no increase in the stress or the load, because the value of the stress corresponding to the point C is known as a yield stress. Yield stress is defined as that unit stress which will cause an increase in the length without increasing the load. Now, the fourth one is the lower yield point. At point D, you can see in the graph over here the point D. Okay, at point D is known as a lower yield point, and after yielding, further stress and strain can be obtained by increasing the load. Ultimate load point. After increasing the load beyond this yield point, stress strain curve rises till the point E, which is known as the ultimate load point. The stress corresponding to this point is maximum and is known as the ultimate stress. At this stage, the cross-sectional area of a particular section reduces very fast. This is called as a neck formation, because whenever you see, if you stretch some object, some elastic object, after certain stretching, you can see the cross-sectional reduction is rapid and very fast. Means at that time you have applied the maximum stress, and because of that, the reduction in the cross-sectional area becomes very rapid. Okay, and that point is known as that phenomena is known as a neck formation. Now next is a breaking load point. Up to point E, The cross-sectional area goes on decreasing, forming a neck. This is a cross-sectional area becoming smaller and smaller. Now the specimen is broken at point F into the two pieces. The point F is known as the breaking point, load point, and the stress corresponding to this point is known as the breaking stress of the material. So that was all about the stress strain diagram. You need to discuss all these points and the regions such as plastic region, elastic region, okay, and the breaking region. Now we will discuss some few important properties of the material. First property is the ductility. If a deforming forces is applied on a material and it acquires a large permanent deformation without producing any fracture, then the material is said to be ductile, and this property is known as a ductility. The breaking point for the ductile material will be very much above yield point. Ductility can be measured in terms of a percentage elongation. Higher the percentage elongation, the more ductile is the material. A body possessing ductility can be reduced from a large cross-sectional area to the thinner sectional. Okay, it can be drawn into wires such as silver, copper, aluminum are the examples of the ductile material. So now next is the brittleness. It is an opposite to the ductility. A brittle structure fractures without any appreciable amount of permanent deformation. Stress strain curve for the brittle material hardly shows any yield point and normally coincides with the breaking point. You can see in the figure. Okay. Now all non-ductile materials are brittle. Cast iron, concrete, and glass are the brittle materials. So compression test is generally performed for testing the brittleness of the material. So it is a compressive quality of the material. Now next comes the plasticity. Some materials are capable of getting deformed permanently without producing any fracture. This property is known as a plasticity and the material are known as a plastic material. Lack of elasticity is known as a plasticity. Now coming to the next topic, that is working stress. So maximum stress applied on a given material within its elastic limit is known as a working stress. A load corresponding to it is known as a working load. So working stress can be defined as the ratio of actual axial load to its original cross-sectional area. For the safety of the structure, it is essential that working stress should be within the elastic limit of the material. So what is the working stress? It is nothing but an ultimate stress, maximum amount of load which you can apply on the body for the safety. That is the working stress. Okay. Now next comes the factor of safety. The ratio of breaking stress to the working stress is known as a factor of safety. So you can see the examples of an automobiles and lifts. Okay, you might be aware about the escalators and lifts. Okay, so in the lift, if you read it carefully, the maximum capacity is 6 person and the maximum load capacity is around 480 kgs. That is some kind of marking given in the lifts. Okay, so what does it means? After if 481 kg is there, the lift will break away? No, that is not meaning. The 480 kg, that is the working stress. It normally works for that. And if in the applications where human lives are involved, the factor of safety is taken as very much higher. In the lifts, generally 6 to 12 is the factor of safety. For example, if factor of safety is 6, means 480 into 6 kg load is applied, till that the lift will survive. It will not break. Okay, so that is all about factor of safety. Factor of safety is nothing but a margin. if in a case, for example, a heavy person like me goes to the lift, okay, so at that time the calculation fails that normal average human being weighs 60 kg, but I have much more weight than that. Okay, so at that time there is a chances of collapse of lifts. Okay, if 6 heavy person are going to the lift, then at that time there is a possibility then lift can fail. So because of the human lives are involved in it, the designer will make sure that lift will not fail under such condition. So at that time, higher factor of safety is needed. Means design is done so that it can carry 6 times much more load than its rated load. Okay, if it is written that 480 is the rated load or working load, then it is capable of carrying 6 times or 12 times load if the factor of safety is 6 or 12 respectively. Okay? So there are various factors affecting the factor of safety. They are the type of material, behavior of a material under different loading conditions, effect of physical conditions such as the temperature, environment, radiations, etc., and the safety of user, as I have discussed. Okay, if human lives is involved, then higher factor of safety is required. Okay. So now in the next video, we will learn elastic behavior of solids, factors affecting elasticity, types of elasticity, types of elastic modulus. Okay, that's it for today, guys. Thanks for watching.